video, we looked at these four market models: pure competition through monopoly, with monopolistic competition and oligopoly in the middle. And the two easiest to analyze are pure competition and monopoly, and right now we're focusing on pure competition. What would it be like to be a firm in a purely competitive market? And what kinds of decisions could you make in order to make your business as successful as possible? We looked at this total cost table here, where a perfectly competitive firm or pure competition firm could produce 0 through 10 units of output, and this is their total cost. And we briefly looked at a graph of total cost and total revenue, assuming that the market price is $350. We briefly looked at how a pure competition firm could try to choose how many units of output they should produce in order to maximize their profits. And we said it looked like around 7 when the price is $350. Now remember that in pure competition, each firm is so small and they're producing exactly the same thing as many other firms, so they have no control over the price. There's a market price that's determined by supply and demand, so the only real choice that a firm has is whether they should produce at all, and if so, how many units they should produce. And that's what we're going to focus on today in this video. So we're going back to look at an example of analyzing a cost table. And this is the most important skill when it comes to analyzing the costs of a firm and analyzing the decisions of a firm. So we did this once before in an earlier video. Let's jump in and do it again to remind ourselves of all of these concepts. So the goal is to be able to take a total cost table, like the one we were looking at the graph before, and from just this information, be able to calculate all these other measures of costs for a firm: total fixed cost, total variable cost, average fixed cost, average variable cost, average total cost, and marginal cost. There are just a couple of key points that you need to know in order to fill out a table like this. The first thing is total fixed cost, TFC. In order to figure out the fixed costs, let's talk for a second about what fixed costs are. Fixed costs are costs that do not increase as you produce more units. The other way we could categorize costs in this context are variable costs, so total variable costs here. Variable costs are anything that do increase as you produce more units. Since when we're looking right here at producing 0 units, this is one option a firm has. Basically what a firm is doing here is telling its employees to stay home that day. We don't want to spend any money on variable costs. We don't want to spend any money on labor or materials. The only costs that are going to be left when you're producing 0 units are fixed costs. So that's key number one in order to fill out a table like this, is to recognize that when you're looking at the cost of producing 0 units, that $640 there are your fixed costs. And since fixed costs do not go up as you produce more units, fixed costs are fixed. They're always $640. As you produce more units today, they don't go up, right? So we could just maybe draw a dotted line here saying that we're just continuing the $640. So $640 in fixed costs here are things like rent for your equipment or your building. The other main kind of fixed costs we want you to think about is the normal profit for the entrepreneur. The return to the entrepreneur profit. But the minimum amount of profit that an entrepreneur needs in order to keep them interested in keeping this business open, we consider that a cost. Just like the land and the labor and the capital have to be paid, the entrepreneur has to be paid. And the minimum payment you can make to that entrepreneur to keep them interested in keeping this business open is what we call normal profit. And that is built in to the fixed cost here. So part of this $640, maybe it's $100 a day. Part of that $640 is a little bit of profit to keep this entrepreneur interested in keeping this business open. Now that we've figured out the fixed costs are $640, we're really breaking our costs into two types here. They're either fixed or they're variable. So in order to figure out the TVC, or the total variable costs here, we just subtract total cost minus fixed costs gives you variable costs. Now remember that variable costs are zero. We're not spending any money on labor and materials costs when we're producing no units. Here, 1,040 minus 640 means that we must be spending $400 on variable costs when we produce the first unit, and so on. $1,280 minus $640 gives us $640. $1,360 minus $640 gives us $720 that we must be spending on these labor and materials type costs. In short, a variable cost is anything that costs you more as you produce more units today. So think about in the short run, today as we're producing more units, anything that costs us more money, that's a variable cost. Anything that doesn't, that's a fixed cost. I'm going to let you pause the video in a minute and finish completing this table, but let's go on and talk about these other 4 items here. Average fixed cost, average variable cost, average total cost, and marginal cost. Anytime you see an A standing for average, average fixed cost, average variable cost, and average total cost, that word average just says we want per unit costs. So average fixed cost here is take the fixed cost, the total fixed cost, and divide it by quantity, and that's going to tell us how much are we spending in fixed costs per unit that we're making. Average variable cost is the total variable cost divided by quantity. We want to know how much are we spending on average per unit for our labor and materials costs. And the average total cost is just take our total cost and divide it by quantity. And that's going to tell us for every level of production, how much money are we spending per unit on average. So we're just taking all of our costs and dividing it by how many we've made so far to get a per unit computation. Average fixed cost, here we'd take 640 divided by 0. Now, we know better than to divide by 0, so this is one of those cases where we're just going to say not applicable, right? Not applicable. Don't divide by 0. Same thing here with average variable costs. 0 divided by 0, not applicable. Average total cost, 640 divided by 0, not applicable. But for any number of units that's not 0, we can calculate this. Average fixed costs when we're producing 1 unit is going to be the 640 divided by 1. That's telling us we're spending $640 per 1 unit, since there's only 1 of them. But when we're producing 2 units, we take that 640 and we divide it by 2. $320 each is how much it costs us for our fixed costs. 640 divided by 3 is going to give us $213.33. Just dividing that $640 by 3, 4, 5, 6, 7, 8, 9, 10 units, right? Average variable cost, doing the same thing but with the variable cost column. 400 divided by 1, well that must be $400 per unit. When we're producing 2 units, it's $640 divided by 2, or $320 per unit for our variable costs. When we're producing 3 units, we're taking $720 divided by 3 gives us $240 for our variable costs, labor and materials costs per unit. And average total cost, we take the total cost column, divide it by the quantity column. So 1,040 divided by 1, 1,280 divided by 2 gives us $640. 1,360 divided by 3 gives us $453.33. And generally here, since what we're talking about is money, I usually round things off to the nearest penny. All right, I'm going to let you fill out the rest of these in a minute, but let's talk about marginal cost. Now, this far along in an economics class, you got to be very familiar with the idea of marginal, additional, or change in. Marginal cost, marginal benefit, marginal utility. So marginal cost is asking, how much additional money does it cost me to produce each additional unit? So when we're talking about producing 0 units, how much money does it cost to produce the 0 unit? Well, that doesn't make any sense to ask, so it's, again, not applicable here. Or you could just draw a dashed line through it if you like. But when we go from producing 0 units to 1 unit, our costs go from 640 to 1,040. And so how much extra cost was there to producing that first unit? Well, the change in cost is $400. The additional cost is $400. And so that is our marginal cost for producing the first unit. What's the additional cost for producing the second unit? Well, our total costs go from 1,040 to 1,280. So the additional cost is $1,280 minus 1,040, or $240. When we're producing 3 units, the total cost is 1,360. So what's the additional cost to produce the third unit? It's just 1,360 minus 1,280. Or another way to calculate marginal cost is to look at the change in the variable cost. The only difference between the total cost and the variable cost is the fixed. But the fixed is never changing, so the marginal cost is always going to be the same if we calculate it as the additional total cost or the additional labor and materials cost. So $80 there. All right, so pause the video and practice calculating the rest of these. We're going to be doing this an awful lot from here till the end of the class, so make sure you can do this very quickly, very accurately, without having to think about it much. So please pause the video, complete the table, and I'll come back and I'll show you my answers. All right, here's the rest of the table and what it should look like. Let's talk about what these things mean just a bit more and teach you some patterns that you need to recognize when it comes to looking at these costs. We're not just doing math for the sake of calculating things. These things are very important, they have important meanings, and they also have important patterns that we want to understand. So first thing I want you to notice here is that average fixed costs is always going to go down, down, down the more we produce. Because we're taking this fixed cost, $640, and we're dividing it by larger and larger numbers of output that we've produced. So average fixed cost is always going to keep decreasing. However, average variable cost decreases, hits a minimum, and then starts increasing again. Same thing with average total cost. Starts high, gets lower, reaches a minimum, and then starts going back up. And marginal cost similarly. Normally, for most businesses that we study, starts off rather high and decreases pretty quickly, and then starts slowly increasing again. One other little trick to help you when you're calculating these things and filling out these tables is that there are actually 2 ways you can calculate average total cost. The first way is what we were doing just a second ago, which is taking the total cost column and dividing it by the quantity. But there is another way. If we take the variable cost per unit, the average variable cost, and the fixed cost per unit, and we add those 2 together, we get the total cost per unit. So here we see for 4 units that 160 plus 220 equals $380 per unit for the total costs. So sometimes that can be a slightly more convenient way to calculate the average total cost. So the next thing we want to do is we want to graph, not all of these items, but 3 of these things, because these are the 3 most important items that are used for figuring out what the decision that a business should make is going to be. And those three items are the last three in this table: average variable cost, average total cost, and marginal cost. So what we want to do is, on this graph that's down below, we want to graph those last three columns. So I'll do marginal cost first. And it's helpful if you have colored pencils or pens that you can do this in. I'll do marginal cost in red. And to help us as we graph these, I copied and pasted these numbers here so we can look at them as we graph them. So marginal cost of the first unit is $400. Marginal cost of the second unit, $240. So I'll put it just below the line that would be $250 here, in between $200 and $300. And then down to $80 for the third, $160, $200, $240, $280, $400 for the eighth unit, $560 for the ninth unit, and then $680 for the 10th unit. And we want to connect these dots with a line so that we can visualize what's going on there with marginal cost. So now you pause the video and graph these other two, average variable cost and average total cost. And again, we can't be too precise as we're doing this. We want to be as close as we can, but we don't want to obsess over getting everything too perfect, because it's just not possible when you're doing this by hand. So pause the video, graph those other two, and then let's come back and look at those. So this is basically what it should look like. And each and every time we graph these three cost curves in this class, these are the general kinds of shapes you should look for. There shouldn't be any weird jaggy spikes anywhere. They should roughly, kind of be smooth here. And the average total cost starts really high, comes down, hits a minimum, and then starts coming back up. And we're interested in that minimum point here. Same thing with average variable cost. Starts high, not quite as high as average total cost, and comes down, reaches a minimum, and then starts gradually going back up. Marginal cost starts high, quickly reaches a minimum, then starts going back up. Now, a few things we want you to think about with these shapes. Average total cost and average variable cost, usually we'll describe these as having a U shape, kind of like the letter U. You have to use your imagination to see this, but it's just the fact that it does have this decreasing sloped portion over here, and then an increasing slope portion on the right side, hitting a minimum, kind of like a lopsided U. And same thing with average variable cost. Usually we'll call these U-shaped cost curves just because they start high, go down, and then go back up. One other thing to notice about this graph is look at the distance between the average total cost in green and the average variable cost in blue. You see how at low numbers of units over here, they're very far apart, like hundreds and hundreds of dollars apart. But as we move to the right, the green and the blue curves slowly start to get closer and closer and closer together. Can you think about why that is? Well, what's the difference between average total cost and average variable cost? What's the one thing that is in average total cost that's not in average variable cost? It's the average fixed cost, right? And that average fixed cost, remember, gets lower and lower and lower as we go. So the difference between average variable and average total cost, if we look at the columns in the table here, we can see that they're slowly getting closer and closer to where at thousands or millions of units, these two will get extremely close. So this is one reason why we don't really need to graph average fixed cost, because we can kind of see the average fixed cost. If you wanted to try to guess how big the average fixed cost is for, say, 4 units, well, we just look at the distance between average total and average variable cost there, and we can kind of get a feeling for it. But the other reason why average fixed cost isn't quite as important is it's not really used in making business decisions, and that's the whole point of what we're doing here. Trying to help this small business figure out how many units to produce, whether it's going to make a profit, try to figure out what it should do. So let's go back up to the table here, and let's answer some questions about the curves and the table as we go. So first, let's look at this question. What is the minimum average total cost? All we're saying is look at the average total cost column here and find the smallest number. So what is the smallest number we see for average total cost there? Well, it's right here at $320. So let's highlight that. That's a very important number that we need to keep in mind. We also want to think about what quantity that occurs at. So if we go over here to the left, we can see that the minimum average total cost is when we're producing 7 units. So what this is telling us is that the absolute cheapest way we can produce this good is to produce 7 units, and when we do that, it's going to cost us $320 each. Why is this important? What it tells us is if the price of this product were ever to fall below $320, there is absolutely no way we're going to be able to make a profit selling this product. Let me repeat that. If the price of the product, think about that as the revenue coming in, if the price of the product is $400, then for every unit we sell, we're bringing in $400. And it's costing us, well, it could cost us all kinds of different amounts depending on how many we make, right? But we know for sure that there is at least one way we could make a profit if the price is $400. And that is, we could produce 7 units. It's going to cost us $320 each. If we have $400 coming in for each unit, and it costs us $320 on average for each unit, we have to be making $80 for each unit, right? But on the other hand, if the price falls below $320, it is impossible for us to make a profit because we can't make them that cheaply. Okay? So this $320 is a very, very important number. Whenever you fill out one of these tables, soon after you fill it out, you want to highlight the lowest average total cost, and you want to make sure you remember that that is what we call the break-even price. If the price is ever above $320, we can make a profit. If the price is ever less than $320, we have to lose money. There's nothing we can do about it. But if the price was exactly $320, we would break even. We could produce these for $320 a piece, sell them for $320 a piece, and break even. Remember, though, one of the most important things to keep in mind is when an economist says you're breaking even, that is not something to be sad about. When you're breaking even, because an economist is making sure that every resource is being compensated, including the entrepreneur, it means that the entrepreneur is making some profit. They're just not making excess profits. They're not making anything above the minimum that is going to keep them interested in staying in this business. So they're okay. They're not sad if they're breaking even. So a price of $320 would not be anything out of the ordinary or shocking for this entrepreneur. Now let's look at another interesting price in this table, and that is to look at the minimum average variable cost. So that's right here. Let's look at the average variable cost column, find the lowest number, and the lowest number is $216. Now this is also a very important number that we have to highlight and keep track of whenever we're analyzing a business's decisions. This 216, the minimum average variable cost, tells us the cheapest amount per unit that it could cost us for variable costs, labor and materials kinds of costs. These are the kinds of things that we only spend money on when we produce more units. So if we produce anything at all, the cheapest our bill is going to be per unit is $216 for these labor and materials costs. Now, why is that important? Well, here's the thing to think about. What would happen if the price ever got below $216? Let's work this out down here. Let's suppose the price was $200, just for the sake of argument. Suppose the price was $200. And let's just suppose, for the sake of argument, that we decided we were going to produce 5 units. What would happen? Well, if our quantity was 5 units and the price was $200, our total revenue, price times quantity, would be $1,000. Well, how much are our total costs if we decided to produce those 5 units? Well, let's look in the table. Total costs, $1,720. All right, $1,720. What would happen to us? Well, profit is going to be total revenue minus total costs. Our profit will be minus $720. Well, that stinks. And it doubly stinks because we could actually do better than that. The worst that we ever actually have to do is to lose $640. So if we ever get to a point where you see that we're losing more than our total costs when we're producing 0 units, that fixed costs, we're doing something wrong. What that's telling us is, in this case, when the price is $200, if the best we could do was to lose $720, there's actually a better solution. We could shut down, which in economics jargon means produce 0 units today. Tell your workers to stay home. Don't use any labor and materials. Use no variable costs at all. And then your total revenue will be 0. Your total costs will be your fixed costs, $640, and you'll lose $640 instead. So you never have to lose more than just paying your fixed costs out of your pocket. This $216 figure here, the minimum average variable cost, is what we call the shutdown price. So let's label that up here. And the shutdown price is a very simple guideline that says, look, if the price ever gets below $216, your best option, without doing any calculations or any thinking, at a price below $216, shut down and produce 0 units. So we have this little rule written right down here. Should I produce at all? Well, that rule says produce 0 if the price is less than the shutdown price, which is just the minimum or the lowest average variable cost ever gets. So the break-even price and the shutdown price are 2 things you always want to make a note of when you fill out one of these tables. Just takes a second, and it's going to help you double check and understand the decisions they should make. Now, there are some more details to cover, though. So why is $216 the shutdown price and not some other number? Well, since that is the cheapest amount we can ever get those variable costs per unit down to, if we produce, any price below that means we cannot even cover our variable costs, much less cover any of our fixed costs, right? The only way to get our variable costs less than $216 per unit is to avoid them altogether by producing 0 units. Now, suppose the price was not $216, suppose it was something higher. What should we do then? Well, let's look at this example here. Let's suppose the market price was $300 a piece. Now, before we get started analyzing what this small business should do, let's just check. First, is that below the break-even price? Absolutely it is. It's below the $320. So we know that the firm is going to end up losing money here. Second, is the $300 below the shutdown price? No. So they should not actually shut down and produce zero. They should produce, but they're still going to lose money. But the point is, by producing, they will lose less than $640, which is kind of that fallback position. If they don't produce anything at all, they have to still pay the fixed costs of $640. So let's see what would happen if they produced and the price was $300 a piece. So here's our rule about how many to produce. Ignore the downward sloping part of the marginal cost curve, then produce as long as price is bigger than or equal to marginal cost. So why is this the rule? Two parts to this. First, ignore the downward sloping part of the marginal cost curve. Why is that? These first few units are pretty expensive to produce because of startup costs. Imagine you had a factory and you hadn't produced anything. You called in all your workers and you produced one unit and then you told everybody to go back home. How expensive would that first unit be? Well, you're going to have to pay people a lot of money to come in and get the factory set up and get their equipment on and everything, and then produce one unit, go back home. That one unit would be very, very expensive. So this is typical with most production processes. The first unit, or sometimes the first few units, are very, very expensive, but that marginal cost will go down very quickly and quickly hit a minimum. So sometimes those first few units are so expensive that if you focused on how expensive they were going to be, you'd never even want to get started producing anything. So that's why we say ignore those first few units where it's downward sloping. Or if you're looking at a table, we can just look here at marginal cost. Ignore the marginal costs where they're decreasing. Start here where the marginal cost hits a minimum. And then what we do is we start asking the question, produce as long as the price is at least as large, greater than or equal to the marginal cost. Now, why is that? Well, think about the price as the money coming in per unit when you sell it. And think about the marginal cost as how much it costs to produce the unit when you produce it. You're doing well if you can produce something for a cost less than the money you're going to bring in when you sell it, right? That's kind of common sense. So if the market price is $300, let's write this down here. So price equals $300. And you can sell every unit for $300. We ignore these first two expensive ones here, and we start asking the question at unit 3. If I can produce the third unit for $80 and sell it for $300, is that a good idea? Absolutely, that's a good idea. Okay, so we'd want to produce the third. Of course, we have to produce the first and second to get to produce the third one, right? We can't just skip over those. What about the fourth unit? It's going to cost $160. We can sell it for $300. Yeah, that's a good idea. The fifth unit? Yep. Sixth unit? Yep. Seventh unit? Yep. Eighth unit. Marginal cost, it would cost us $400 to make that eighth unit. And then we turn around and sell it for $300. Does that sound like a good idea? No, that would be a terrible idea. So what this is suggesting is if the market price, which we have no control over, was $300, then we should stop at the 7th unit and not produce the 8th unit. So Q equals 7. And again, our prediction here is because that price of 300 is less than the break-even price of 320, we predict we're going to lose money here. We'll see if that's right. Total revenue, 300 times 7 would be $2,100. How much is the total cost of producing these 7 units? Well, we just look up here at the table. Total cost, 7 units, $2,240. So total cost equals $2,240. Our profit, revenue minus costs, equals negative $140. Well, that kind of stinks. Now, it doesn't stink as bad as our other alternative today, which is to lose $640. right? We have these contracts to pay for these fixed costs, and there's nothing we can do about them. So today, if the price was $300, we have two choices. Come into work, produce, and lose $140, or shut down and produce zero and lose $640. I'll take losing $140 any day if that's my best alternative. Now, we're not going to do this forever, though, right? All we're talking about right now is today, what is our best choice? Well, today, come into work, produce the 7 units, and lose $140. But we're not going to sit around and do this forever. If we think nothing's going to change, if we don't think the price is going to go up, or if we don't think there's anything we can do to lower our costs, then in the future, just looking at this list of questions here, right? How many should we produce? 7. Will you make a profit? Nope, we're going to lose $140. Should we produce these units today? Absolutely. But what should we do in the future if we don't think anything's going to change? Well, we need to start making plans to exit this industry. Two common terms that are pretty confusing that we need to get straight. Shutting down means produce zero today. But if we're thinking about permanently closing this business down and going and trying to find something else to do, the term is exit the industry. That's a long run thing that we can't really exit the industry today. We've still got all these contracts and these fixed costs. But in the future, if we don't think things will improve, the permanent closure is called exiting the industry. Because we're not going to sit here and lose $140 every day forever. That negative 140 tells us that there's some other better use for our resources. So we ought to convert these resources somehow into using them in some better use. Now let's go back and answer a couple of these other questions up here. Now we looked at the minimum average total cost, which again we call that break-even price. And we looked at the minimum average variable cost, which is the shutdown price. And I want us to think real quickly about why these things are where they are in the table and why they are where they are on the graph. Let's look at the graph. I think it's a little bit easier to see this in the graph instead of looking at the table. The minimum average total cost occurs at 7 units. So let's highlight that right here. And the minimum average variable cost occurs at 5 units right here. An interesting relationship here is between the marginal cost and these minimums. And in order to help you understand this relationship, I want you to think about grades. Let's look at average variable cost first. At the very beginning over here, let's suppose this is the very beginning of a semester, and at the very beginning of the semester, your first test, you get a 400 on. Think about that as your marginal test, an additional test in a class, right? But it's just your first test. So in your marginal test, you get a 400. What's your average test grade? That would be the average variable cost here. Well, it's 400. They're the same, right? Now, your average is 400, but then your additional test, your next test grade, is about a 240. What's that going to do to your average when you score a 240 and your average is 400? That's going to pull your average down. The relationship here that we want you to get between the marginal and the average is anytime the additional cost or the additional test grade is below your average, it pulls your average down, down, down. But as soon as these two lines cross, see this crossing point right here where marginal cost crosses the average variable cost. As soon as those two cross, what it means is that your additional test grade or the additional cost is higher than average. And when you add in additional scores or additional costs that are higher than average, it starts to pull that average back up. And we see the same thing happen to average total cost for exactly the same reason, except it happens at a different place. The minimum average variable cost happens at 5 units. It keeps getting pulled down until 5, and then because of that crossing after 5, it starts to pull the average variable cost back up. The same thing happens with average total cost, except here it happens right here where those two cross, just past 7. So because those additional costs are below the average total cost, it keeps pulling the average down, down, down. As soon as the marginal cost crosses, it starts pulling the average total cost up, up, up. So this is a way to understand why it is that these minimum of the average variable cost and the average total cost happen very close to where the marginal cost crosses these two curves. And also why it happens at two different places, because the marginal cost crosses the average variable cost before it crosses the average total cost. So that's what I was getting at with these questions here. At what quantity does the marginal cost cross the average total? At what quantity does the marginal cost cross the average variable cost? To try to make sure you understand that. And to reiterate one last time, the idea is simply that when the cost of an additional unit is less than the average, it pulls that average down. When the cost is higher than the average, it pulls that average back up. It's just as simple as that. All right, let's go through one last example because I feel like we're kind of having a down moment with this person always losing money. So let's do one last example, and let's suppose that the price in this industry really went up, and let's give this person a profit. So we can choose any price here that is bigger than the break-even price, right? Now what was the break-even price again? $320. Okay, let's pick a price that's a lot bigger than the break-even price. Let's say $560. So let's suppose the price was $560. Let's see how many units this person should produce and how much profit they're going to make. So again, our rule is, should I produce? Well, we should produce some units if the price is bigger than the shutdown price, which 560 certainly is bigger than 216. So how many should we produce? Ignore the downward sloping part of the marginal cost curve and then keep producing as long as price is bigger than or equal to marginal cost. Okay, well let me erase these check marks over here and let's go through it again. So we ignore these first two and we start when the marginal cost is at its lowest point at 80. And we say, price is 560. Should I produce that third one? Yes. If I can sell it for 560 and it costs me 160 to make, should I do that? Yes. And the fifth one, cost 200, sell it for 560. Yes, 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 yes. Now wait a minute, here's the interesting case. The ninth unit is going to cost us $560 to make it, and we can sell it for $560. What should we do? Well, let's look at the rule first. Produce as long as price is greater than or equal to marginal cost. Well, that price is equal to marginal cost, so this rule is telling us to produce that one. Now, this is a tricky case, but I do want to make sure you know the answer we want you to give, and then I'll convince you that that is indeed the best answer. So the answer we want you to give is, even if the marginal cost is equal to the price for that last unit, go ahead and produce it. That's what the rule says, and that's what we want you to say. So the right answer, produce the ninth unit if the price is 560. We're not going to make any additional profit off of that ninth unit, though. It's important to know that. It's going to cost us $560 to make, and we're going to sell it for $560. So our profit will not go up because we produce it. It's not going to go down, though, either. So why do it? Let me give you a couple of intangible kinds of reasons why this is a good idea. It's not going to make the entrepreneur more profit, but it is likely to make your employees happier, and that's an important thing in business. And it's also likely to make your customers happier. So let me ask you a question about employees. if you had a choice, suppose your boss came to you and gave you a choice and said, hey, we could stick around and produce one more unit for another couple of hours, and I could pay you more if you stay a couple of hours longer. Would you rather stay a couple of hours longer or go home early with less money? What answer are you going to give the boss? Now, most people, unless you're 16 years old, now I remember when I was 16 or 17 and I had a job at the pizza place, the boss would come around and I knew the boss was looking to ask people, things are getting slow, I got to let somebody go home. As soon as he started looking around like that, I would say, ooh, can I go home early? Can I go home early? But that's before you have kids and that's before you have a mortgage, right? Whenever you've got real bills to pay, most of the time you're going to be happy to stay a little bit longer and earn a little bit more money. So your employees would rather you keep them and pay them rather than send them home and pay them less. So that's one reason for producing that 9th unit instead of sending your employees home early. Another reason would be, think about a customer. Customer comes up and says, hey, I need a unit, and you've just produced your 8th unit. And you tell the customer, well, we were thinking about going home. How much are you willing to pay for this unit? And the customer tells you $560. And you say, hold on, let me check my books. And you look at your books and you see that it's going to cost you $560 to make it. And the customer is offering you $560 to pay you for it. You can either tell that customer no, go away, or you could say, I'm not going to make any money off of this, but because you're a good customer, just this once, I'll do it. I'll have my workers stay later, and I'll have them make this for you, and you pay me $560. That's really just what it's going to cost me. I'll do it for you. You're going to have a happy customer. If you send them home without anything, they might go find somebody else to do the work for them next time. Okay, so long story short, produce the 9th unit. Your profit's not going to go up, but produce it anyway. So what's going to happen here? Well, if the price is $560 and we're telling you that you should produce the 9th unit, so Q equals 9, how much is our total revenue going to be? $560 times 9 is $5,040 in total revenue. And how much is our total cost? It's $3,200. So total cost, $3,200, and that's going to give us a profit of $1,840. So this is pretty much all of the important information that you need to know about how to fill out a cost table, how to use a cost table, the relationships between these different cost curves, why the minimums happen where they do, and how a business should choose to maximize their profit in the short run. So they have the choice of how much to produce, or they could produce zero, which we call shutting down. In the long run, if they're losing money now and they don't think that's going to change, in the long run, they might look to exit this industry, which means a permanent closure and letting these resources go find something better to do where they can be more profitable and productive. So there's one last important topic that we'll cover in the next video when it comes to perfect competition, and that is, how can we look at the decisions that this one firm is making, where we see as the price gets higher, this firm is going to decide to produce more and more and more units. It's kind of like their supply curve. How can we take the decisions of one of these small, pure competition firms and take into account how many total firms there are in the industry to derive the supply curve for the entire market? That's what we'll look at next time. So as always, if you have any questions about anything that we were doing in this video, anything that wasn't clear at all, please let me know. I'll be happy to help you and try to answer your questions. Otherwise, this is Dr. Berkey signing out, and I hope you join me next time. I wish you the best of luck in all your studies, guys.